Hi there. Let us look at the conformationally mobile systems. So these are like the cyclohexane rings that we can draw using different conformations or Newman projections that are always having different conformations. So because they are conformationally mobile, it means they are ways by which each person could draw them. So assuming we have this first one, we can try to find whether this molecule is mesocompound or whether it is chiral. So in other words, whether it is going to have a mirror image or whether it's going to be superimposable. So by having this molecule, we can do a ring flip. So if this is position 1 and that is 2, we can do a ring flip and this becomes position 1, that becomes 2. We can also flip it like a pancake and then we end up with that other one. Now when you look at it, you might think this could be a mirror image of the other one, but then we have said they are conformationally mobile. So because of that, we need to redraw it in a conformation where we can easily tell whether we can have a plane of symmetry or whether we can have them as being mirror images. So the way to do that is to transform this molecule into a Hayward projection. So this is up, this is also up. So if we do a Hayward projection, we're going to have those on the same side. Whichever way we draw it, the similar groups here are going to be on the same side. And when they're on the same side, now we can be able to determine if there's an internal plane of symmetry, and then we can classify the compound as being a chiral meso compound. So make sure when you're given these molecules, redraw them and then be able to determine if there is an internal plane of symmetry using the Hayward projection.